Folks, hello and welcome to week 7. I'm going to give you a little more help here on some of these homework problems in the Q theory section. That is a kind of a large and laborious section, and with the number of different Excel files that you have available to you in that student companion area, I just want to make sure I can help you match up a couple more of these in the homework. So I'm going to apologize right off the bat here because I'm going to have a couple different windows open here and a bunch of different Excel files open here, but I'm going to see if I can give you a little more help on this. So just bear with me and we'll see if we can get through this. So let me see. Let me go back to a couple problems that I just picked out here for you. Yeah, this one here. So this is another algorithmic problem. Gubser Welding Incorporated operates a welding service for construction and automotive repair jobs. Assume that the arrival of jobs at the company's office can be described by a Poisson probability distribution with an arrival rate of 2 jobs per 8-hour day. The time required to complete the jobs follows a normal probability distribution with a mean time of 3.2 hours and a standard deviation of 2 hours. Answer the following questions. So in this case, notice that we have a little bit different situation here on the service rate. And if you go to the list of, let's see, these are the options again in your student companion site where you pull down these Excel files. This single arbitrary file, I've already got it open, is the one that I'm going to use, and I'll show you why here in a second. Here is the single arbitrary. Again, this allows you to kind of play around with this, and the arbitrary, I should say, being this service time, service rate, and the fact that you have a standard deviation. But this problem starts just like all the others in the sense that we need to know the arrival and service rate. So let's see, I think there was something here that said, assume that the arrival of jobs at the company's office can be described by a Poisson distribution with an arrival rate of 2 jobs per 8-hour day. So 2 jobs per hour, the arrival rate will be a quarter of a job per hour. And then the service rate says, excuse me, the time required to complete the jobs follows a normal probability distribution with a mean of 3.2 hours and a standard deviation 2 hours. So the question is, what portion of the job do they do in an hour? So I'm going to go over here and say equals 3.2 hours times 60. So the total amount of time is 192 minutes. So out of every 60 minutes, so let's say 60 divided by 192, so every hour, it looks like they're doing about, let's see, about 31% of the job. So the service rate is going to be 0.3125. And then the standard deviation, we can throw that in there just as it is. That is going to be 2 hours. And so once you manage that, here are the Q characteristics. And if you, let's see, if you go over here, I think these all match up pretty well. Let's see, what is the mean arrival rate? I talked that through with you here. If it's 2 every 8 hours, so it's a quarter of a job per hour. And then the mean service rate, make sure, again, you understand, and this is an algorithmic problem, so your number is going to be a little bit different, but the approach should be the same. So 3.2 hours, I converted that to minutes. So if you take that as the denominator, 60 over that will tell you what portion of the job is completed with an hour, and that's again about 31.25%. Excuse me. And then I think all the questions here basically line up with your Q characteristics. So you should be in pretty good shape on that one. So let me see. Let me get rid of that. And let's see. The next one I wanted to pick out here. Yeah, this is an interesting one here. Midwest Publishing Company publishes college textbooks. The company operates that should say a 1-800 telephone, a toll-free number whereby potential adopters can ask questions about forthcoming texts, request examination copies of texts, and place orders. Currently, 2 extension lines are used with 2 representatives handling the telephone inquiries. excuse me, calls occurring when both extension lines are busy. I'm sorry, calls occurring when both extension lines are being used receive a busy signal. No waiting is allowed. Each representative can accommodate an average of 11 calls per hour. The arrival rate is 22 calls per hour. So in this case, what I'm going to do is I'm going to open up, let me show you here first in the list. I think what I'm going to use here is this multiple. Actually, I'm not using multiple. I'm using no waiting here. And again, it was made clear that there is no queue here because there is no waiting. So let's see. I should say there is no extended queue for lack of better terms. Let me see. Multiple server. Yes, I think this is the one I have here. So if I go to multiple, let's see, which one did I? Sorry, I used no waiting. Sorry about that. I've got too many things open here. So I use this no waiting model. And let me see, let me pull the question back up. So let's see, just as a reminder, the number of servers is 2. The total arrival rate, excuse me, is given as 22 calls per hour. And then let's see, the service rate for each server is 11 calls. And so that is the input in this situation. And then the operating characteristics, and this will align with the reading in the textbook. First of all, notice that we have 2 servers. And so this distribution here actually considers up to 4 servers. So what we want to notice right away is that the probabilities of number of servers being busy will just be these 4 or these 3 values over here. Let me just highlight that to make sure that you know. Obviously, if you were to add up these probabilities, they would exceed 1. But because this is this chart will accommodate up to 4 servers, in our case, we will disregard 3 and 4. And all we want to look at here are the number of servers busy being either 0, 1, or 2, and the associated probabilities. Obviously, those will add up to 1. So we're in good shape here. So the way that these questions are being asked, how many extension lines should be used if the company wants to handle 90% of the calls immediately? So if I look at this line right here, line 22, probability of callers will be blocked. And so we want to make sure that the 90% of the calls are handled immediately. And so what we're going to do here in this case is we're going to just increase, what we can do using the model is increase the number of servers. And let's see how, number one, how the operating characteristics change. And then this probability callers will be blocked. And so if we continue, let's continue to ratchet this up. So if we go up to 3 callers, let's first of all make sure that equals, let's make sure that this thing's doing what it should be. The sum of these 4 values, this should equal 1, which is good, right? So these number of servers busy and the associated probabilities. So probability callers will be blocked. This you should see that this number went up just a bit. And then if we go to 4, again, let's make sure that this distribution is doing what it's supposed to do. And that's good as well. So I think what we're looking for here, how many extension lines should be used if the company wants to handle 90% of the calls immediately? And so in this case right here, we have exceeded 90%, and we have done that by adding 2 additional servers, which takes us up to 4. So the 4 that you see here, and again, making sure that you look at the probability callers will be blocked at this 0.90. The fact that this exceeds 0.9 will answer this question for you here. Then it says, question B, what is the probability that a call will receive a busy signal if your recommendation in part A is used? So that's just going to be, if these are blocked, then the busy signal is over here, and this will be 1 minus the complement, or the complement of that 1, which is 1 minus 0.9048. And so this 0.0952 is the value that you see in this case. And then finally, let's see, what number of calls in decimal form receive a busy signal for the current telephone system with 2 extension lines? And I think if we just go back to 2 and the number of busy, let's see, number of servers being busy is 2 extension lines, and that 0.4 is the 0.4 that you are looking for there. So I hope, let's see, I hope this is helpful. Let me just mention here, when I opened up this Excel model from the Student Companion site, in order to get the macros to work, I had to take this file, I had to enable it, and I saved it to my desktop, and then I opened it from my desktop. And then once I saved it, I was able to use it. And that's very similar to that finite file that you are going to use for your case study this week. So this is a couple more. I think this gets us through about 3/4 of these. And then if there's any more questions on the others, we can use the chat forum and make sure that everybody has what they need to get through with these. So thanks and enjoy the rest of your week.